So here we have an initial value problem. Our variables are y and x. Doesn't have to be t. Often these are modeling something that's dynamic, changing over time, so often our independent variable is t, but it could be whatever. First of all, let's consider any equilibrium solutions by setting our function of y equal to 0. So there's an equilibrium solution at y equals 0. Now let's go ahead and separate variables. So we'd have a dy, and if we divide both sides by y squared, I'm going to write it as y to the negative 2, and then e to the negative x and dx. Now we are ready to integrate both sides. And so antiderivative here, this is going to be negative 1 over y. And then this will be negative e to the negative x, and then plus our constant of integration. Now if we can solve this for y, we'd like to. So let's multiply both sides by a negative. That will make that a positive. We multiply by negative 1. I'm just going to call that another constant. Often with your constant, instead of having it a constant times 2, that's just another constant. A constant times a negative, that's just another constant. So we'll leave that as a constant. And then we're going to multiply both sides by y. Essentially what this does is ends up taking reciprocals, but I'm writing out the steps to show us that. And last step would be to divide by this so that the y was alone. And so what we have is y equals 1 over e to the negative x plus a constant. Now, that is our general solution, gives us our family of solutions, and we want the specific one where at 0 it equals 1/2. So we would now take y of 0, that's going to be 1 over e to the 0 plus c, and that needs to equal 1/2. And so we can see here that, because this is a 1, that c would need to equal 1. So our specific solution for this initial value problem is 1 over e to the negative x plus 1.